Let's go ahead and get started. It is 7 o'clock here at the Milwaukee Makerspace on a Monday, so that means it's time for Model Monday. And we're going to model up a useless box is our project for the next couple weeks here. Let me kind of fade out our Model Monday beat here. Let's kill that down. Alright, cool. So like I said, useless box is our project for the next couple of weeks. And what does that mean? What is a useless box? Well, a useless box is something like this. I just did a kind of a basic Google search for useless box and came up with, basically it's a box that has a switch on the top. And the entire purpose of the box is to turn itself off. So as soon as you flip the switch, it turns on and turns the servo, and the servo flips the switch to turn itself off. So that's kind of the entire purpose of a useless box. But for us, it's an excuse to draw some stuff. So let's go ahead and do that. I'm going to start a new project just by going up to this tab up here at the top where it says New Design, and I'm going to go ahead and click on that New Design tab, and we've got a new document going on here. So I've got my part, and a piece of caliper is what we're going to be modeling as a servo. So I'm actually going to come and steal that servo from you, Mike, if you don't mind, and I'll steal my caliper. Beautiful, thank you. Alright, so the bonuses of coming to join us in person for Model Monday is you get to go ahead and grab the part that we're going to model a little bit early and grab some measurements from it. So I've got this servo here, and I've got my calipers, and I'm going to be kind of shouting out some measurements as we start our sketch here for those of you joining us here, and for those of you joining us at home or via the recording after the fact. So I'm going to think about this servo as kind of one sketch. I think I'm going to draw this mostly as a single sketch. So it's going to be kind of a top-down view here. So I'm going to draw most of this servo, kind of thinking about it from this perspective. And I'll go ahead and start by starting a new sketch here. So I'm going to come up to the Create menu, and I'll choose Create Sketch. And I'm going to go ahead and create that sketch on my front plane. So I'm going to hover over that little yellow plane, and you can always navigate using the navigation cube so you can see it a little bit more easily if you're having a hard time selecting the right plane here. And I'll click on that, and it'll spin me around to look straight down on it. And now we can start by making a rectangle. I should mention, in general in this class, and it's probably a good thing to mention every time we start a new project, is in the document settings over here in our browser on the left-hand side, we can spin down the document settings option here, and you can see that I'm drawing in freedom units. So my brain tends to think in freedom units. If you want to draw yourselves in international standard that's accepted by pretty much the rest of the world, feel free to do so. I support that decision. However, I'm going to draw in inches. You'll have to do that conversion in your brain hole. And if you're drawing in millimeters, you're smart enough to make that conversion on your own. I'm certain of it. So I'm going to come up to the Create menu and come down to Rectangle. And I'm going to choose to make a 2-point rectangle, I think. I'm just kind of looking at my part and seeing if there's a reason to make anything other than a 2-point rectangle. And I'm going to say no. So I'm going to go ahead and grab my 2-point rectangle tool. And I'll click to place the beginning of my 2-point rectangle right there at the origin. And then I'm just going to move my mouse out. So it's a click and move, not a click and drag. I'm not holding my mouse button down while I do that. And we are going to make this rectangle exactly 1.5925 inches. And then if I hit the tab key, the other measurement here, and I'm just kind of measuring up my servo here, it's 0.7835. So 0.7835. And I'll just kind of leave those measurements up there for a little bit, and I'll kind of zoom in here. I'll kind of do this periodically throughout class today is I'll make a measurement, because we're going to be doing a fair amount of sketching, and I want to make sure you guys catch all these numbers. So something you'll notice is we've got some rounding going on here. You know, I feel like there's a way to change this. I think is it in properties? I feel like there's a way to change the default setting for decimals. And maybe that's not really important for this class. But now I'm just kind of curious. In our design, we're actually in our... There's not. There probably is a way to change that. I just don't know it right now, so we're going to move on. Alright, so the next thing I'm going to think about drawing on or modeling on this servo part here is there are wings, our kind of mounting points here. Our mounting points are actually a different width than our servo body, and we can draw that on here. So I'm going to go ahead and grab my 2-point rectangle tool again. So I'm going to go ahead and say create rectangle and then 2-point rectangle. For those of you trying to impress your friends at home with your keyboard shortcut skills, you can use the R key. Now, and you notice if I hover over the middle of this line, I get that little blue triangle. And that blue triangle is telling me that I'm snapping to the midpoint of that line. And that is indeed what I want to do here. So I'm going to snap to the midpoint of this line, and then I'm going to move my mouse out here, and it's going to come out to a depth of, you know, I can do it like this. And grab this measurement here of 0.265. That's going to be inches. And if I hit the tab key, now I'm only drawing from the midpoint out here because I know that this little thing is centered on the on my servo here. So I'm going to measure the width of the whole thing here, which is 0.7225. And then I'm going to do some math right here. So I measured this as being the entire width of this object here, this mounting point, but I'm actually just going to say divided by 2, and that's going to give me half of that because I'm drawing out from my center point out here. That saves me from having to measure whatever that small amount, whatever this tiny amount of space is off here to the side. It's kind of difficult to see, but you can see the servo is not quite the full width. That mount is not the full width of the servo. So that saved me from having to do that. And now, in order to get the other side of this, actually before I do that, let's go ahead and draw our circle in the middle of this thing. So we are going to draw a circle here. So I'm going to go ahead and grab my create menu and circle, and then I'm going to choose to make a center diameter circle. Now I'm not really placing this at any particular place right now or any particular location right now. I'm just placing it in roughly the spot that I want to put it here, and then we'll negotiate it into place after we have it drawn. Now the width, the diameter of this circle is going to be 0.17. inches. And I'm going to go ahead and hit enter here. And now I'm going to move it into place. So something you'll notice about my sketch so far is most of the sketch lines I have here are black. And that is because those sketch lines are kind of fully constrained. So they're locked in position and in dimension. So they're not going to move because they're locked in position with my center point here, with my origin, and they all have dimensions. Now this circle that we just placed is blue, and that's because the circle is not fully constrained. It's not locked in position. It's locked in dimension. So here's my dimension of that circle right there, but it's not locked in position. And we're going to lock that in position now. So I'm going to go ahead and grab from my constraints menu, I'm going to go ahead and choose this tangent constraint. And I'm going to say, make this circle tangent to that line. And it's going to go ahead and lock it in position left and right. So now this circle will always be tangent to this line here. And now I'm also going to give it a dimension from this other line here. So as you may know, in addition to giving dimensions to the sketches that we make, we can kind of add dimensions to relate objects to each other, if that makes sense. So in my Create menu, I'm going to go ahead and scroll all the way to the bottom and choose this Sketch Dimension option. So I'll choose Create and then Sketch Dimension. And now I'm going to dimension the center of this circle and this line down here at the bottom, the edge of my mount for this servo here. And now I'm going to move this measurement out and just place it. So now you can see our circle is now changed to black, so it's fully constrained now, only it's constrained to the wrong dimension. So we need to fix that. So if I measure, let's go ahead and zero this out again. If I measure the gap between my circle and my edge, it's 0.0835. And here's where I'm going to do some math again. So I've got 0.0835, and that's the distance between kind of this edge and this edge here. And then I'm going to say that that is minus the radius of my circle. So the radius of my circle is going to be 0.17 divided by 2. And you can see I put that, oh, it doesn't like what I just typed there. Doesn't like that at all. Why won't it let me do that? Do I have to type in inches here? Why you no likey? Do I have to type in inches here? Alright, what is the part that it does not like? It likes that. Can I do minus 0.17? Nope. Can't subtract, apparently. I can add. Nope, can't add either. Why can't I add if I put a 0 before that? Well, it was letting me do math before. Why won't it let me do math now? It's always fun when you can't do things that you feel like you should be doing. Oh, okay, so minus 0. Well, I'm just going to go ahead and do that radius right now. 0.17 divided by 2. I don't have my phone on me. Does anybody have a calculator handy?
What's the number?
0.17.
0.17 over 2?
Yeah.
0.085.
0.085. It really doesn't like to do that. Oh, is it because it's... Alright, so I guess we're going to have to do this differently. That's going to be plus 0.085. There we go. Didn't like it because it was going to give me a negative number. Alright, so now that is our placement for our mounting hole finally. And now the last thing we need to do here is to create the rest of our mounting holes here. So we're going to have the same pattern over on this side, and we're going to have the same pattern over on this side, and we can do that by using the mirror command. So I don't need to redraw this whole bit of stuff here. We can use the mirror command in order to create all the rest of our shapes. So if I go ahead and click on create and then come down to mirror, now I can specify each one of the lines that I'm going to mirror. So I just need the circle and these two outer lines here that are part of our mount. And then the line that we're going to mirror this off of is this line right here. This other edge of our rectangle. And you can see it kind of ghosted in place there. And I can say OK. Now I'm going to do the exact same thing, except I'm going to mirror all these things over to the other side. But if I'm going to do that, I need a line to draw, I need a center line to mirror across. And I can do that with our line tool using that midpoint option. So if I move towards the midpoint of this line with my cursor, you can see that little blue triangle pops up, and I'll just do the same thing over on this other side, and now we've got a line that divides our piece right in half here. And I'm going to do one additional thing. So I can take this line, and notice if I hover over this part of my rectangle, it selects differently from this other part. So this is divided into two individual rectangles right now. But if I don't want that to happen, and I really don't because it's going to make me extra work later when I go to extrude this, I can change the line type from this solid line. Over in my sketch palette, I can click on this construction line option here. And now this is just one solid body or one solid shape with a construction line dividing it. Alright, so we can do that same method that we did just before. We can click on create and then come down to mirror. Now I have a whole bunch of objects that I want to mirror. Actually, not really a whole bunch. I got several objects that I want to mirror. And there are a couple of ways to select objects in Fusion. So I can go through and click on these individually and go through and select all those options. Or there are select tools. So I've got my window selection checked here in my select menu up at the top. This is kind of my preferred method of selection. And in order to select all of the sketch items that I wanted to select here, there are two ways that I can use this tool. So I can click and drag. I can click and drag from top left to bottom right. And now you can see that my selection box is a blue line with an orange filling. And the way that that tool works is only the items that are fully inside of that selection box will be selected. So this line was not fully inside of that selection box. This line was not fully inside, neither were these circles here. So the only thing it picked were these lines up here. If I use the tool the opposite way, if I click from top right and go to bottom left, you can see I got a yellow selection tool. And this yellow selection tool will select anything that it touches. So regardless if it's fully enclosed by my selection, if it's touched at all by my selection, it'll get selected. And that's a good method for me right here. I'm going to go ahead and choose my mirror line and say OK. Alright, so now we're going to do a couple more things on this sketch. So I'd like to sketch the shaft of my servo on this sketch here. And we're going to locate the shaft of our servo very similarly to how we located our circles over here, our kind of mounting hole circles. So I'm going to come up to my Create menu, and I'm going to come down to Circle, and then Center Diameter Circle. You know, before I do this, let me just kind of do a check-in. How are you guys doing? Are you with me? Are you following if you're choosing to follow?
So.
Yeah? Do you want me to pause and see how you're doing? Or just take a little brief pause for the cause here and you can, catch up? Dan, how you doing?
I am going to do it by the YouTube video later because I got locked out of my
Cool.
Fusion account.
Right on, alright. So we're just taking a little brief pause as we get a few people to catch up in class. I tend to go real fast. So there's another benefit of like coming to class in person is if you need a little bit extra time, I will 100% give that to you. Or like Dan's going to do, he's just going to pause the video every 5 minutes. There you go. All right. While you're catching up, I'm going to measure this servo here. All right. You good? Ish?
Hey, goodish.
Goodish? Okay.
Yes.
So the shaft of this servo is 0.23. It's 0.23. Yeah, 0.23. All right, so I'm going to go ahead and grab my circle tool. I'm purposefully kind of making this in the definitely wrong position, so because like I said, we're going to constrain it, use constraints to force it into position. So I'm going to place this kind of off to the side here. I'm going to add my dimension that's 0.23 inches, and I'm going to go ahead and click enter. Now the circle is definitely centered right to left on this on our drawing here. So I can constrain this right to left in our drawing using some existing lines that we have here. So there is a constraint called the horizontal vertical constraint. This is kind of a new thing that I'm doing, is like using these constraints more often, and this horizontal vertical constraint is nice. So what it says is if I choose the center of my circle and then I choose either one of these, any one of these points here that is the end point of that kind of center line that I drew initially that was part of this mounting bracket, so I can click on this point over here or one of these points over here, what will happen is this circle will always say, hey, I'm straight horizontal from that point. So if I grab my move tool, I can only move it, even though I'm moving this up and down, I can only move it right or left because it's got a constraint that is forcing it to be directly horizontal from this point right here. So now it's constrained in one direction. Now I just need to constrain it in the other direction, and I'm going to do that in a little bit because we've got a couple other concentric circles that we're going to draw around this, and it looks like the final concentric circle is tangent to this line up here, so I'm going to go ahead and wait to constrain that until I have my other circles drawn. And speaking of, oh boy, Enter. Alright, so now I'm going to draw my 3 other circles, it looks like here. So I'm going to draw one circle that is 0.4225. So I'll grab my circle tool, 0.4225. Now I will say that this is way overkill for what you need to have to make it. If you're going to draw this, model this servo, the amount of detail that you will need to have in this in order to create something that is functional, or that is what do you say, that is accurate enough that you could put it in a drawing, or put it in an assembly, and be able to pull use for information from it, is less than what we'll have going on here. But it's fun to try to make things like as super accurate as possible. So that's kind of the method that we're using here. So this final circle is going to be 0.78. I feel like this was 0.7825. Alright, so I'm going to take a little pause here because I drew a lot of circles, and each one of them has a measurement that I've kind of got concentrically pulled out around the outside here. So we've got 4 total circles and a center shaft circle. So I've kind of got them arrayed here. This is really useful to be able to reposition these measurements wherever you need them, so they can make you have a nice clean looking drawing. So I'll just take some time to kind of clean up my drawing and really make it easy to read here. That's always important. Somebody once told me that when you have a drawing like this, you're supposed to have all the measurements should only be on 2 sides. I don't know if anybody else prescribes to that suggestion. I'm not following it here, but if you feel like there's a reason to do that, go ahead and yell at me in the comments. Alright, so now we've got a whole bunch of circles drawn here, and now we're finally going to place these in position. So we've got them constrained kind of in this Z direction here, in the up and down direction. Now we're going to constrain them in the final direction, because this circle is going to be tangent to this line here. So if I go ahead and grab my constraint, my tangent constraint from the constraints menu, and I choose this outer circle here, and then I choose our line, now it's going to go ahead and move them all into position, because all of these circles share a center point constraint. They all have that because I chose to make the start of my circle at the center of the last one. They're all kind of holding on to each other in that way. Now the last thing that we want to do here is to create the last little bit of this this shape here, and I'm going to do that. This is 0.7 even. So I'm going to go ahead and grab my rectangle tool one more time, and I'm going to place the first point of my 2-point rectangle is going to be at the center point of all those circles, and I'm going to make this out in this direction. It is going to be 0.96 by 0.7 divided by 2. Because I'm choosing to do this halfway again, because I'm going to mirror this over the other side. Really? There we go. Oh, do I have that the wrong direction? This way it is 0.93. And if I hit the tab key, it's 0.7 divided by 2. Alright, so let me move those measurements so they're more easily read here. So now I just have to mirror this shape over. So I'm going to go ahead and grab my mirror tool here. And I'm going to mirror these two lines here right over that center line and say OK. Alright, so I'm going to do a couple of things here that I don't do all the time, and I'll explain to you why after I do them. So I've got a lot of lines that are kind of overlapping here, and I don't really want that. So I'm going to use the trim tool. The trim tool is in the modify section here, so if I click on modify and come down to trim, this trim tool will allow us to kind of cut off the edges of the parts of the line that we don't need. So this last concentric circle and this rectangle, this is kind of all part of the same shape. So I can use this trim tool to cut away the parts of this line, parts of this circle that I don't need. So the way the trim tool works is it looks for intersecting lines and cuts away the bits in between them. So I can click on that part of the circle there and cut it away. I can click on that part of the circle there and cut it away. I can do that with this center line here, although I don't know how that'll affect me later. So I'm kind of trimming away all of the individual parts of that center line to get rid of them. And I'm also going to trim away these parts of the line or the rectangle that extend beyond the circle here. So that line and that line and that line and that line and that line. Now the reason that I've done this is all of this I'm going to extrude as one piece, and it just makes it easier for me to select one object to extrude, or one enclosed area to extrude, than it is to extrude out, click on all the little individual pieces. The other reason is it just looks cleaner, right? Now, Fusion is currently swearing at me. All those lines are red. And the reason that they're red is because I deleted a lot of valuable geometry, frankly. So I deleted this center line here, and the center line was my mirror line. So the method by which this line and this line appear over on this side no longer exists. You can also see I lost my dimensions because I deleted that, cut away that center line there. So if I want to change dimensions here on this object, it will not behave in predictable ways when I go and change those dimensions. So I don't often advocate the use of the trim tool for things that you're going to need to change, or you may need to change, but these measurements are pretty set in stone. We got our part right here, so and I'm confident that I measured it properly. So we're just going to roll with it, and I get to show you how to use a tool that we don't use a whole lot of. Alright, now that is pretty much it for this sketch. I'm just kind of looking at my part, and almost everything is modeled or almost everything is drawn on this single sketch, which is convenient for us. So I'm going to go ahead and click on Finish Sketch here. Now I've got a Sketches folder over here in my browser, and I can go ahead and name this. This is my servo. Servo with an R. Actually, I could go ahead and call it a servo body. It's not really a body though, so bodies are a whole different thing. I'm just going to call it servo. Alright, now we can start extruding the parts of our servo here. And we've got everything drawn in one sketch, so we're going to need to make use of an offset tool as we extrude. Maybe we won't actually. Alright, so I'm going to start by extruding kind of the main body of our servo. So I'm going to spin this a little bit more of a three-dimensional way. How you doing, Mike? Do you have a sketch?
Yes.
Sweet. Alright, so I'm going to go ahead and click on Create, and then I'll choose Extrude here. And I'm going to extrude all of the parts of this servo that are inside of my kind of main body here. So everything inside of this, that big rectangle that we drew when we first started, that's all going to get extruded. And it's going to get extruded a distance of 1.44. So I'm going to go downwards here, kind of away from my sketch. I guess this is technically backwards because I drew on the front, so I'm moving towards the back. And I can see that it's a positive number when I'm moving in that direction. You can see if I move in this direction, it's a negative number. I'm going to extrude some things in that other direction. So I want to make sure that I type in the right positive negative value here. So this is going to be 1.44. And for me, it's a positive number. For you, it might be different. So, Fusion is a mystery to me about negative and positive numbers. Sometimes I think it should be obviously negative. Like here, I'm going towards the back. So to me, I don't know why that should be a positive number, but it is. So positive 0.144. I'm going to go ahead and click Enter. Now we've got a bodies folder here, and this bodies folder has a body in it. So I'm going to go ahead and name that body my servo body. And now I can keep extruding things. So from my servo, I'm going to extrude the outermost ring of our shape here. So this shape right here is going to be extruded up and away from the body of our servo. 0.095, no, 0.1. 0.1. And now this is going to be a negative number. So it's going to be negative 0.1. We'll bring it up. So that creates the first little step up in our servo here. Now the operation I'm choosing is indeed going to be join. You can see that, if we move it down, the operation defaults to cut, and that would be cutting away from this shape. So it's always interesting to know that you can cut away from a three-dimensional shape using a sketch. But join is what I want here, so I'm going to choose OK. Now I'm going to extrude the next segment of our servo, of our little concentric rings there. So I'm going to go ahead and click on my extrude command, and then the next full circle there is going to come up a distance of, just going to eyeball that because we got to get close-ish for government work. It is 0.1155, and again, for some reason for me this is a negative number. And I'm going to say OK. Now lastly, actually not lastly, I'm going to extrude the next little segment of our circle, which is going to be 0.13, negative 0.13. And this is also going to be a join, so we're joining those together, and I'll say OK. Now we need to extrude the shaft. Shaft! Gotta have that theme song play. When my dad's not in class, I don't have him to sing the song for me. Or say things like, "You damn right." Alright, so the last extrusion is going to be the very inner circle there, and this is our shaft. So our shaft is 0.31, negative 0.31 for me. I'm actually going to choose to make this a new body. Eventually, I think I'm gonna make a joint out of this, and if I want to make this spin in the model, make a joint in the model where it can spin like my servo can spin here. So I'm going to need to make it a new body in order to do that. So I'm going to go ahead and choose this new body command and say OK. And then that means I'll have one more additional body over here that I can call servo shaft. Now the last items that we need to extrude from our servo sketch here is our mounting holes. And we can extrude those from this sketch, even though the plate for our mounting holes starts kind of below our sketch level. So you can kind of imagine like this top surface here, that's where our sketches exists. But we're going to extrude down here by using an offset. So if I go ahead and choose my extrude tool, and then I pick each one of these little mounting brackets here. Now the thickness of this mounting bracket is 0.0955, which is going to be positive for me, 0.0955. Yep, so downward into my shape is where I want to go with that. Now the mounting bracket is not right at the top surface of our servo here, so it's not right up at this level. It's down here, an offset amount. It's down there a distance of 0.229, and we can extrude from that distance by changing the start plane here. So normally when we extrude something from the surface that it's drawn on. So our sketch is drawn on a particular surface here in space, and we extrude from that. But right now, what we really want to do is extrude from an offset amount from our drawing surface. So if I make that offset amount 0.229, and for me, again, this is going to be a positive number. For you, it might be different. It could be a negative number depending on how Fusion is orienting your drawing. So like, just for example, if I change this to a negative number, you can see that it's clearly kind of in the wrong position here. So that's your clue that you need to multiply by -1, or just change your negative to a positive. Change those negative to positives and turn that frown upside down, and then you'll be having a good drawing, and you can hide your servo sketch, and there is the beginnings of a pretty sweet looking servo, if I do say so myself. Now the last thing I want to do here is to kind of model the port where our servo cord comes out here. So So we got to have room for this in whatever enclosure we build around our servo. You want to make sure you account for this little dangler there. And I'm going to do that on the top side of our servo. So I'm going to spin around to this side here. Oh, you know what? This extrude, I can see I've got some extra bodies over here. And I don't want that, because it changed from join to new body accidentally. So if this ever happens to you, down here in our timeline, we can right click and I can say edit feature. It's interesting that it doesn't have that one selected. Alright, so now instead of new body for an operation, I'm going to go ahead and say join. Because I want this to all to be one big, happy, joined together family. Alright, so there's our servo body, and like I said, we're just going to draw this little port up here where our cord comes out, just so we have that located for our drawing. So I'm going to grab my Create Sketch tool here, so I'll click on this Create Sketch icon in my Create menu, and then instead of specifying one of these 3 drawing surfaces, you can draw on any flat surface. So this surface here, which is the shaft side top of our servo, I'm going to call that, is where I'm going to draw this little port. So if I click on that, now we're going to draw a rectangle. So if I click on Create, and then Rectangle, and then 2-point rectangle, our rectangle is going to be 0.155 by 0.255. So 0.155, and then I'll hit the tab key. 0.255 is the dimensions of our rectangle. And we just need to place that in space here. So again, it looks to me like it's centered on our object here. Only I believe that we don't really have a midpoint on either one of these to choose here. So I'd like to use that same horizontal vertical constraint that I used before, right? The same way I marked the center for placing this circle here, I'd like to use that same method on the side, but I don't really have a midpoint or a point to click on. We really need to have points here. So we can add them. In the Create menu, there is a very underutilized option here in the drawings that just says point here. So instead of a line or an arc or a circle or whatever, we're just going to make a single point. And if I place that single point on the midpoint of this line, you can see I've got a blue triangle that says I'm snapping to the midpoint of this line. And I can place that point right there. And I can do that same thing over on the edge of my other surface here. I got that little blue triangle. So I'm snapping to that midpoint, and I can click and place that point. So now I've got 2 points that are constrained on their individual rectangles. So now when I choose that constraint, horizontal vertical constraint, and I choose the first point that's on my rectangle here, I'll mention, like, this rectangle I want to move. So as a general rule, at least most of the time in Fusion, I can't think of a time when it's other than this, the object that you want to do the moving, you choose that first. So I want to move this object to that point. So now you can see it's constrained in one direction, and I can constrain it in the other direction by adding a dimension constraint, just like we did that very first time. So if I click on the Create menu, and then I choose this Sketch Dimension option here, I can click on the bottom of my line, and I can click on the big huge line here that represents the bottom of my servo, and I can place that dimension, and now I can actually measure that dimension as being 0.15. There we go. That is all we need to do on that sketch. So I'm going to go ahead and click Finish Sketch here. And I'm going to name this sketch. This sketch is my chord. Good enough. Anything is better than sketch 2. And now I can extrude a little piece from that. Extrude, I'm just going to choose that little piece right there and extrude it out. This is coming out a distance of 0.2. Not super crucial, but we just want to know where that chord comes out just for reference so we don't accidentally not make room for our chord in our final piece. So this is our sketch here. This is really the crux of our servo. Now I'll do just a little bit of cleanup here. So the servo I'm looking at has a lot of soft edges, and the bottom here, actually the bottom of this servo is actually filleted. So it's got not filleted, it's chamfered. So in the modify menu, if I come over here to this chamfer option, I can choose each one.
Could you just choose the bottom edge and that would select all of them?
You sure could. So I could choose this bottom face here, and it's going to go ahead and pick every edge that are on that face. And gosh, this chamfer is, I don't even know how to measure a chamfer. This one looks like it's 0.09. Yeah, that. I don't know how that's measured. I wonder if that chamfer goes like 0.09 in like X and Y, or if it's like a diagonal measurement. But at any rate, this is just kind of like a cosmetic thing for us. So I'm just gonna, it looks like it's less than that. I'm gonna go 0.05. It doesn't look like much of a chamfer on this at all. And I'll say OK. Now our servo is full of hard edges, and there are very few hard edges on this thing. So I'm going to add a couple of fillets. The first thing I'm going to fillet is these edges over here. So like that edge on all the sides here. So I'm going to click on Modify and then choose Fillet. And I'm going to pick each one of these little edges here that are kind of the edges of my mounting hole, and just give them a decent little fillet there. And then the last things that I'm gonna fillet are almost, looks like all of the edges around this kind of main part of the body here are filleted, all the ones that aren't chamfered at least. So in the modify menu here again, I'm going to choose fillet, and I'm going to pick each one of these lines. Now you can get sometimes into a little bit of trouble when you pick too many things to fillet at once. Sometimes sometimes Fusion will say, nope, can't do it, does not compute. And you just have to kind of do things one at a time and figure out which is the specific fillet that is giving you problems. I'm going to make this a real small fillet. It's just a real soft little edge. Again, this is super unnecessary, but if we're trying to make things look as cool as we possibly can, and we definitely are, then adding some fillets, some real small fillets does that. And then as a bonus, just because we got a couple more minutes in class, how you doing on fillets, Mike? You got a drawing that you're happy with?
Yeah.
Sweet. So the last thing that I want to just kind of mention is right now our servo is just kind of all one color. It looks super boring. And you can, sometimes it's useful to have things that look like they're made of different materials, right? So our shaft is not going to be made of the same material that our servo body is. And we can add some materials to our object here. So if I click on this modify menu and come down to appearance, I should mention that I guess there's two ways to do this. So there's this appearance option, which is the option that I often choose, and then there's this physical material. So both of these will achieve the same visual result. However, I guess maybe we should do physical material because this maybe is a better way to do it. Physical material also includes things about its weight and its machining properties. So if you're going to machine something, if you've added a physical material to it, the machining part of Fusion 360 goes, hey, this is made of aluminum, so I'm going to find you a feed and a speed rate that's good for aluminum. It also, we could do things in Fusion where we, do centers of mass, and maybe that changes for various materials. So you can figure out the weight of an object. So if you've drawn something and you want to know how much it's going to weigh, if you give it a physical material, it'll tell you how much it's going to weigh, if it's made of lead or if it's made of ABS. And those two will obviously be different. So if I choose this physical material option here, this window looks exactly like the appearance window does, except it says physical material at the top. So we've got a whole bunch of materials here, and if I come down to this plastic folder and I spin that down and I choose this ABS plastic, which is, I'm sure, what this servo body is actually made of. If I choose this ABS plastic and I click and drag, and I drag it either out on top of my body here in the drawing view, or I can drag it on top of my body in my bodies folder here. So I've got this bodies folder, or I can drag it right on top of here. Now it changes white. Our servo is totally not white. It's a bad idea to have a white servo. They will just look dirty all the time. So if I double click on the material, this ABS plastic material in my physical material folder, oh gosh, I guess I gotta click on advanced. Yeah, so this is a little bit different than in the appearance window. So if I double click on that and then I choose advanced, and then I can pick the appearance tab, then do I have to double click on that? Wow, this is a lot different. We might just leave it white. Because normally oh gosh, you have to pick this RGB thing. Wow. Alright. So here I've got an RGB value. Can I pick on edit color? That's what we want to do. Alright, so in this parameters window here, sorry, this is more complicated than I thought it was going to be, Mike. We're going to click on this little arrow here and then choose edit color. And now we can go ahead and take our little slider bar and move it down into the black area. I find that you probably don't want to go full black because everything just kind of disappears. If we go mostly black, like really deep charcoal, that'll be good. And then you can say OK, and then OK. And now we've got a nice black servo body. And we can do one last thing, because the shaft of our servo, I'm sure, is brass. So if we click on this metal here and scroll down past all the aluminiums, or aluminum if you prefer, you can find this brass option, and I'll click and drag this brass option on top of our servo shaft. And then that's it. I'm going to say close. We've got our servo body here modeled up. The beginnings of our useless box. I'm going to go ahead and save this. And I'm going to make a new project for this. So this is our servo. And I'm going to go ahead and make a new project. This is our useless box. And inside of that useless bots project, I'm going to go ahead and save this servo. And I'll just say save. Cool. So that's it for Model Monday today. Next week maybe we'll make our switch. So we're going to need a switch that's part of this. And if we have time, we might try to make our box next week too. And then what'll be the fun part of this class, and the interesting part I think, is when we come and add joints, because I want to be able to make, oh boy, I clicked on a thing. I want to be able to show you how to make things move here in Fusion finally. So we'll add some joints that'll kind of let us figure out how this box is going to turn itself off. And you maybe be able to find a unique way to turn off your useless box by using the joints here in Fusion 360. So, but next week we'll switch and box. We'll make the switch first, and then a box to hold all the stuff. And we'll see you next week, Monday.
Okay.
Oh, thank you. All right, I just gotta figure out how to stop the recording now.